Consider you have this radical equation shown below. So let's say we have the square root of x minus 3 plus 6 is equal to 8. Now, how can you go ahead and solve that radical equation? Because we have square roots and stuff, so those are called radicals. So how can we go ahead and solve that? What you don't want to do is square both sides. If you square both sides, then you're going to have to FOIL, and that's just going to be a waste of time. What you need to do, since the 6 is being added to the square root, you want that square root by itself, and then you can square both sides. Otherwise, you can't square both sides at this point. First of all, you want to get rid of the positive 6, that way the square root is by itself on one side of the equation. So let's just get rid of the 6 by subtracting both sides of the equation by 6. So we're going to get the square root of x minus 3 is equal to 8 minus 6, so it's equal to 2. The square root of x minus 3 is equal to 2. Now at this point, what we need to do is, since we have the square root on one side of the equation, in order to get rid of that square root, we don't want that square root, right? We want to get rid of the radical. So what we need to do is square both sides. Because if we do so, the square and the square root cancel each other out, and we just have a simple algebraic expression. And that's what you want. You just want a simple algebraic expression, and so that way you can solve for x very easily. So the square root and the square root cancel. We get x minus 3 is equal to 2 squared, which 2 squared is 2 times 2, so it's 4. Now at this point, we have a very basic equation, which I assume that you know how to solve. So what we're going to do is add 3 to both sides. That way x is equal to 4 plus 3, which is 7. That is the value of x. Now you can go ahead and plug that value of x inside the equation. If you plug in 7 minus 3 is 4, the square root of 4 is 2. 2 plus 6 is equal to 8. And so you do get 8. So x is equal to 7. That is indeed the right answer. Now let's try another example, a harder one though. So let's say that we have 5, hang on, let me just get rid of all this. Okay, so let's say we have 5 times the cube root, so we have 5 times the cube root of x plus 2 minus 4 is equal to 5. No, let's make that 6 actually. Let's make that equal to 6. So how can you go ahead and solve the radical equation? First of all, you don't want to divide both sides by 5. If you do so, we're going to get cube root x plus 2 minus 4 divided by 5, and that's going to be more complex. Since we have the cube root being subtracted by 4, what I recommend doing first is adding 4 to both sides, just to make it more simpler to get rid of that negative 4. So what we're going to have is 5 times the cube root of x plus 2 is equal to 6 plus 4, which is 10. Now at this point, what I recommend doing is, since the 5 is being multiplied to the cube root, if you don't see a symbol there, it's multiply. Since 5 is being multiplied to the cube root of x plus 2, we just want that cube root by itself. That way we can cube both sides. We want that cube root by itself. So what we're going to do is divide both sides by 5 in order to separate the 5 from the cube root. So we're going to have the cube root of x plus 2 is equal to 10 divided by 5, which is 2. Now at this point, this is when you want to cube both sides, because we have the radical on one side of the equation, and we want to cube both sides. That way the cube and the cube root will cancel each other, and we'll just be having x plus 2 is equal to 2 cubed, which is 8. So we're going to cube both sides in order to get rid of that cube root. So the cube root cancel. We get x plus 2 is equal to 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. Now we have basic equations, so we're going to just solve for x by subtracting both sides by 2, and we're going to get x is equal to 6. So that is the answer for x. X is equal to 6. And you can plug it in. 6 plus 2 is 8. The cube root of 8 is 2. 5 times 2 is 10. 10 minus 4 is equal to 6. So indeed, that does work. Now let's try another practice problem for you to become good at radical equations. So let me just get rid of this and that. Just quickly do as fast as possible. Okay, so let's say if we had 3 times 2x minus 4, 2 to the raised to the 2/3 power plus 5 is equal to 17. So what do you think the first step should be? Like, okay, by the way, if you know how to solve this equation, go ahead, pause the video, work out this example by yourself, and then once you have the answer, play the video and see if you got the answer correctly, and watch how you work through these more complex examples as we move on. Now, the first thing that I recommend doing is not dividing both sides by 3. That's just going to make things much more complex. First of all, I just recommend getting rid of this positive 5. So what we're going to do is just subtract both sides by 5 in order to make that simpler. So we're going to be having 3 times the 2x minus 4 to the 2/3, and this is equal to 12. Now, at this point, what we need to do is, since the 3 is being multiplied to the 2x minus 4 to the 2/3 power, to separate the 3 from this radical. By the way, you might think this is not a radical, but this is actually a radical. This is the same as the cube root of 2x minus 4 raised to the 2nd power. But yeah, what I recommend doing now is dividing both sides by 3 to get rid of this 3 and just be having this radical by itself. So let's divide both sides by 3. This cancels. 2x minus 4 to the 2/3 is equal to 12 divided by 3, which is 4. Now, at this point, what I recommend doing is, in order to get rid of this exponent, what do you think we need to do? The best thing I recommend doing is raising both sides to the reciprocal. So, and the reciprocal basically means flipping the fraction. The reciprocal of 2/3 is 3/2. We just flip it. Let me give you an example. If we, what is the reciprocal of 5/6? Flip it, we get 6/5. Just know that. Now we're going to raise both sides to 3/2 power. And the reason why we want to do that is the 2's will cancel and the 3's will cancel. And all we have left over here, we don't need the parentheses. It's just going to be 2x minus 4. We want to get rid of that exponent, so what we did is raise both sides to the reciprocal in order to get rid of the exponent and just be having 2x minus 4 to just keep it simple on the left side. Now, what is 4 raised to the 3/2? What is that equal to? 4 raised to 3/2 is the same as 4 to the 1/2 raised to the 3rd power. Now, 4 to the 1/2 means the square root. The square root of 4 is 2. And 2 cubed is equal to 8. 2 cubed is equal to 8. Let me just get rid of that. 2 cubed is equal to 8 because 4 to the 3/2 is 4 to the 1/2 cubed, and the square root of 4 is 2. 2 to the 3rd power is 8. So 4 to the 3/2 is equal to 8. Now, this is a basic equation, so we're just going to add 4 to both sides. I assume that you know how to do this. So, now 2x is equal to 12. If we divide both sides by 2, we're going to get that x is equal to 6. X is equal to 6. And you can plug it in. If you plug in x equals 6, 2 times 6 is 12 minus 4 is 8. The cube root of 8 is 2. 2 to the 4th. 2 squared is 4. 4 times 3 is 12. 12 plus 5 is equal to 17. So, x is definitely equal to 6. So, as you can see, x is equal to 6. Let's try this example. What about this practice problem for you to try at home? Let's say, or maybe you're at a movie theater or something, whatever. But let's say you have, why does this take okay. Sometimes it takes time for me to get rid of this, but hopefully you're understanding a pattern on how we're solving these radical equations. Understanding sometimes there are different types of radical equations, and hopefully you're seeing the varieties and what techniques you have to use for different varieties of radical equations. So let's say we had the square root of x plus 1. Let's say it's equal to 2x minus 13. Okay, so go ahead and solve for x. This one is just going to be very simple because we had the radical by itself, we have the square root by itself, so it's going to be very easy. All we have to do is just square both sides of the equation, because whatever you do to one side of the equation, you have to do to the other. And the reason why we squared both sides, the square root cancel each other off. So we just get x plus 1 is equal to, now here we need to FOIL. I'm going to write this a little bit smaller because here we're going to have to actually FOIL. So we're going to be having, x plus 1. Now 2x minus 13 squared is the same as 2x minus 13 times 2x minus 13. Perhaps you've heard of FOIL, FOIL, first, outer, inner, last. So we're going to FOIL this expression. 2x times 2 is 4x squared, 4x squared. 2x times negative 3 is, it's better. 2x times negative 3 is negative 26x, but negative 13 times 6 is also negative 26x. Negative 26x minus, or negative 26x plus negative 26x is negative 52x. I just combined those like terms right away. And negative 13 times negative 13 is positive 169. Now, what I recommend doing is whatever we have on the left side, what I recommend doing is moving it all the way to the right side. I recommend moving x plus 1 to the right side. And as we do so, when we subtract both sides by x and when we subtract both sides by 1, the signs will obviously change. So we're going to be having, because we're moving everything from the left side to the right side, so we're just going to be having 0 on this side because we moved everything from the left side to the right side. Now, negative 52x minus x is negative 53x. And 169 minus 1 is positive 168. 168. Now at this point, we need to use the quadratic equation to solve for x. I do not recommend factoring this because you would have to do 4 times 168, which is a large number, and you would have to find two numbers and multiply to the product of 4 times 168, and that satisfied the sum of negative 53 as well. And that would take you a long time. So instead, what we're going to do is use the quadratic formula in order to solve for x. So let's use the quadratic formula to solve for x. And if you don't know what the quadratic formula is, it's basically the quadratic formula is, for some reason I can't get rid of this, but yeah. The quadratic formula is the x equals negative b plus or minus the square root. Let me write it here. The formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in order to do that, we're going to have to use the quadratic formula, which does take a long time, but it's going to be x equals, now negative b is, that's negative, well, negative b, a is negative 50, b is negative 53, and negative times negative 53, that's just going to be positive 53. So that's going to be positive 53 plus or minus. Now I'm just going to do the arithmetic very fast here because negative 53 squared is the same as 53 times 53. And 53 times 53 is actually, well, 53 times 53, we can just use a calculator for that. 53 times 53, just give me a moment for that. 53 times 53 is 2,809. And that's going to be 2,809 minus 4 times a, which is 4, times c, which is 168. And then we need to divide it by 2 times 4, which is 8. And when we do that arithmetic, what we're going to get is x equals 53 plus or minus 11 divided by 8 when we use the quadratic formula. And then the other answer that we're going to get is, well, we need to break it up. We're going to get x equals 53 plus 11 divided by 8, which is 61 divided by 8. So x equals 64 over 8, sorry. 64 over 8. And then which is equal to 8. So we can clearly see that x is equal to 8. That's one of the answers for that one. Now 53 minus 11 is 42. And then 42 divided by 8, well, we can just reduce that to 21 divided by 4. Or x equals 5.25. Let me just get rid of this stuff. I know I didn't show all the arithmetic because that would just be a lot of me writing it. I just kind of did it in my head really fast with the calculator, obviously. But yeah, let me just. But when we do that arithmetic, we're gonna get the answers, that is x equals 8 and x equals 5.25. So those are the two solutions for that example. X equals 8 and x equals 5.25. So those are the answers for that equation. So we had to use the quadratic formula for that. I didn't show me using the quadratic formula. I kind of just did the calculations in my head sometimes and with the calculator. And you get x equals 8 and x equals 5.25. Now what we're going to do is try another practice problem for you to try. So let's say we have a radical being added to another radical. So square root being added to another square root. That's going to be kind of interesting. So let's try that. Just get rid of this. Okay, let's say if we have the square root of x plus 5 plus the square root of x, and let's say that's equal to 5. Why not? Let's say that's equal to 5. So go ahead and try that example. Shouldn't that be 4? Well, yeah, that should be 5, yeah. Now, what we're going to do is we want to move the less complicated square root to the other side. So what we're going to do is subtract both sides by the square root of x. That way we're just going to have the radical x plus 5 is equal to some constant, and then we can easily just square both sides. So hopefully you guys are seeing like a pattern on how we're solving these. Make sure you don't memorize this, but try to visualize how you're doing this, okay? So it's going to be x plus 5 is equal to 5 minus the square root of x. Now, at this point, what we're going to do is square both sides to get rid of the square root. Because all we're going to have on the left side is just x plus 5 if we square both sides. Now here, we're just going to have to FOIL. So we're going to have x plus 5 is equal to 5 times 5 is 25. We're going to get negative 5 root x. And then we're going to also get negative 5 root x. So this is going to be negative 10 root x. And then this is going to be negative root x plus times negative root x is positive root x squared. And the square root of x squared is simply x. So that's what we're going to be having. Now what we're going to do, what I recommend doing is subtracting both sides by x. We're going to subtract both sides by x. That way this will cancel. And this will also cancel. And we're going to get the constant 5 is equal to 25 minus 10 times the square root of x. Let me just get rid of some of this part. let's just focus on this equation. How can we solve this equation? Let me just get rid of this part, okay? So how can we solve that? So in order to solve 5 equals 25 minus 10 times the square root of x, what I recommend doing is moving the 25 to the other side. That way we have the radical by itself, like I say. So let me just rewrite it here. We have 5 equals 25 minus 10 square root of x. We want to move the 25 to the other side. That way we have the radical by itself. So we're going to subtract both sides by 25. 5 minus 25 is negative 20. Good, negative 20 equals negative 10 times the square root of x. Now what we're going to do at this point to get the square root by itself is divide both sides by negative 10 in order to get the square root by itself. Negative 10s will cancel. Negative 20 divided by negative 10 is 2. So we're going to be having 2 is equal to the square root of x. Now I assume that you know up to this point in the video. I think you know what to do. We're just going to go ahead and square both sides to get rid of the square root of x. That way we're just going to have a constant is equal to just x, the answer. So we just want to square both sides to get rid of that pesky square root. So this will cancel, square will cancel. 2 squared is 4, and we get 4 is equal to x. So that is the answer for that. So as you can see, hopefully you're getting a visual understanding on how to solve these radical equations. You have to do different things. Sometimes it got complex, like the last one, quadratic equations we have to use, and different varieties of them. Sometimes you just gotta square both sides. Sometimes you gotta deal with the rational exponents like we did. And so hopefully the video helped you out with different varieties. And also, if you plug in 4 equals x, that's gonna be well, that's gonna work. The original equation was like something, but like if you go back in the video and if you plug in 4 equals x, you're gonna get the answer. You're gonna get yeah, it's gonna work. It's not gonna be extraneous, but yeah, it's gonna actually work. So that's the answer to that problem. So hopefully now you know how to solve different varieties of radical equations.